My name is Dave Anderson. On Twitter, I'm Dave Anderson without the vowels. My talk today is called Choose Your Own Adventure for Client Web Services with GraphQL. Before we start, a little bit about me. I'm a developer consultant at Stride Consulting in New York City. I'm also a co-host of the Definitive Developers podcast, where we talk about human factors of software engineering and also technology like GraphQL. That's episode number 52. Check it out. I've worked with GraphQL for almost a year now. And the latest thing that I'm working on is with the developers at Jor, like Piero over here, who you may have seen give a talk on performance in GraphQL on Friday. So at Jor, we're implementing a lot of these concepts using Python with Graphene and JavaScript with Apollo. Both Stride and Jor are hiring. Jor is creating an office in Madrid, so if you're curious about getting out there, reach out to Piero. Cool. So before we start the adventure, I have a prologue. As a developer, we face choices with web application development every day. In the vein of classic choose your own adventure books like these, or more modern ones like Romeo and or Juliet, the choices we make for the initial design of our API and the evolution of that design over time can have drastic impacts on the consumers of our API, both internal and external. Those choices have consequences, though hopefully those consequences are not as extreme as those in the classic choose your own adventure books. I don't know of anyone who's ever been dismembered by an API. So GraphQL offers an alternative to REST API. Just a show of hands, who's heard of GraphQL before? Who's used it before? Cool. So GraphQL, in a nutshell, it offers better tooling, so more developer happiness. We can also choose to fetch exactly the data that we want in a single request to our API. And it also has a pretty straightforward development workflow, allowing for pretty efficient development. It's becoming more and more popular with major players in technology, like GitHub, Facebook, Yelp, New York Times, Twitter. The list keeps on growing every day. So it's pretty cool. So on our journey, in the style of a modern web development choose your own adventure, we'll explore the benefits and trade-offs between REST and GraphQL. So that's GraphQL, it's a rocket ship. And you got a sailing ship. Slow and steady, it's REST. We'll build up an example schema using a choose your own adventure story as the example. So it's kind of meta, but it'll work. And we'll also explore some advanced considerations like performance and scaling. All right, let's start. Chapter 1, API architecture and design. You're a developer. Maybe you're building a rich web experience, like a single page app using JavaScript and a framework like React, Angular, or Vue. Maybe you have multiple clients besides web on mobile platforms like iOS and Android. Maybe you have an external-facing public API for use by clients with many diverse needs. One thing's for sure, you need a really robust API. So, what do you choose? If you choose REST, go to the next section. If you choose GraphQL, skip to the following section. So REST is a pretty common choice, so let's stick with that. It's comfortable. So choosing REST. With REST, it's a familiar design decision. It's basically become the default for any new API for organizations to build since the original dissertation on REST in 2000. So I'm sure everyone in this room has touched a REST API in some form or another. But just a quick review. With REST, we use HTTP verbs like get, post, put, and delete to interact with resources like stories in our choose your own adventure. So we can get a list of stories that we have in our database, or we can get a particular story in our database using the ID as a URL parameter. And we might create a new story using post, or update a story using put, or delete one using delete. Pretty straightforward. So when we have more resources, we'll build more endpoints. So in addition to the stories endpoints that we created earlier, we might have passages for the different pages in the story and choices for the different options to branch between the choices that we have. So we can nest these endpoints together. So passages are related to stories, so we'll nest that together. And choices are related to passages, so those can be nested as well. It's all open-ended. You can design it however you want. You can flatten it out if you need to. But we're still going to be interacting with these through the standard HTTP verbs. There's also not really a standard structure for the response. Typically, people use JSON. You might use something called HADOS, which is Hypermedia Engine of the Application State, which is an idea that you'd only return a very normalized state for the response. So if we get from our API stories endpoint, we might get the exact data, or all the data that's available for the story, like their title, author, or description, and a link to all of the related resources. In practice, there's often a lot of denormalization, so you might get a list of passages in the endpoint itself. It's not standardized, so whatever works for you. So as time goes on, you receive many new requests to add fields to the API. But as a result of that, if you have many clients, some clients may be fetching fields that they don't require. And that could be additional network overhead, additional server overhead, and general slowness, especially for mobile clients. You might want to deprecate old fields or refactor existing fields. So you might introduce a set of version endpoints like V2 stories or V3 stories. But if you have mobile clients that you can't control when they upgrade, and you need to keep those clients active, you might be supporting those multiple versions of APIs forever, which is a pretty common thing that has happened to me in the past. So at the end of all this, you're attacked by a sea monster with as many arms as your API has versions and endpoints, and you die. It's a little dramatic, but these are hard problems, and people have thought about good ways to solve them, but maybe there's a better way. So let's get back and choose GraphQL. So your friend tells you about a new way to design API introduced by Facebook called GraphQL. So choose to explore a little bit deeper. GraphQL is a query language for your API. It allows clients to ask questions of the server and get exactly the data they need in a single request. So that means that your server doesn't have to care exactly what the use case is for each client that needs to consume the data. And that's very powerful. It gives you a lot of flexibility for your clients. So how does this look in practice? You define a schema. What we see here is the GraphQL schema definition language that is used to describe GraphQL endpoints regardless of the platform. So this is specific to the GraphQL standard that's open source by Facebook. So again, we have our story, passage, and choice types. And for each type, like our story, we have all the fields and types defined for it. So our title is a string, our author is a string. We might define a relationship between stories and passages as a list of passages, which is a custom type that we define here, with, again, the fields and types that we want here, like strings and booleans. And again, for choices, we also have fields. And we can, again, relate back to the next passage. So that's the passage that our choice will lead us to. Tying this all together, we have a root query object where we define what are the fields that you can access by default as you're starting your query. So in this case, we have story. We may provide a parameter of ID so that we can specify which exact story we want. And yeah, so the next, we write our query against the schema. So in this case, we have a query which we've named myStory, which is just an arbitrary name for the operation. And we access the story ID of 1. So that'll return back just the one story we care about. And we may only care about ID and title, and we don't care who wrote the story. We don't care about the author, so we don't want it. We can also ask for a list of the passages for that story. and some specific fields. When we send that to server, we'll get a JSON response back. And that JSON response will only have exactly the data that we asked for. So we'll only get the ID and title for the story, and for each passage, we'll only get the ID, name, and description without the extra fields that we don't want. If we need to change data, we can write a mutation. So we don't have HTTP verbs like put or delete to interact with our API. Instead, we need to write a mutation. And here we have a create story mutation. That's the name of the field that we've defined on our mutations. And that takes an input of title, author, and description. And after it performs that operation of creating the story, it'll return back some data about the story. So in this case, we can access any type on the story. So we'll ask for the ID, title, and description, and author. In practice, when you're creating a new record like this, especially with like an advanced client like Apollo, you'd want the ID back so that you can update your local cache. We'll get into that a little bit later. So, as you're building your application, you have awesome tools that you can use to help you. So one of those tools is GraphQL. That is a tool that we can use to prototype our queries with completion and all kinds of nice features to help us explore the documentation up there in the corner and see the result of our queries in real time. This is really helpful when you're on your local environment and you're experimenting and seeing what the best form for the query is. So in this case, we got the title and description, and we got back the title Romeo and Juliet, and we have a description of that. So it says like, what if Romeo never met Juliet? What if Juliet got really buff instead of moping around the castle all day? What if they teamed up to take over Verona with robot suits? So that's our description. And we can also get the passages as well. So we have all these initial passages that are available. We're using a relay connection, which is a method for pagination, and we can get the first 5 passages in the story through that. Cool. So another tool that's pretty helpful is GraphQL Voyager. This here is the GitHub API. So there is a lot of data available in GitHub's public API. I would definitely recommend that you check it out if you haven't already. It's pretty cool. So we can zoom in and look at the root query. So these are all the fields that are immediately available for you to query. And that might lead to the user object. And on the user leads to an organization. And the organization, that leads to a project. So that's pretty cool. Like, anyone can really use this tool. It's even available for non-technical people to understand what the shape of your API is and how you can work with it. Another cool tool is GraphQL Faker. So this is a tool that lets you get prototype data for APIs that don't even exist yet. So in this case, we're getting employee data. Every time we hit it, it's going to be random employee information. So it'll be randomly generated using the Faker library in JavaScript. We can also add fields very easily. So in this case, we can add a catchphrase for each of the employees using Faker's hacker phrase. So each employee has some kind of elite hacker phrase that they'll be known for. And then if we go back to our query, we can add that field, even though it doesn't exist in our server, and get back data that has some information. It's something like CSS microchips, I don't know, just gibberish. But it's pretty useful if the API doesn't exist yet, especially if you have a stark separation between the front end and back end teams. So initially, when GraphQL was open sourced by Facebook, we had only the reference implementation of GraphQL available in JavaScript. But now we have plenty of choice. We have clients in Elixir, Scala, Android, Ruby, and of course Python. So which platform are you going to choose? If you choose Python, go to the next section. But it's a Python conference, so we're definitely going to choose Python. So if you choose Python, you're going to choose Graphene as the framework of choice. It's the most popular framework right now for building GraphQL APIs in Python. And if you're using Django, there are Django bindings for Graphene as well. And they're pretty helpful. One example of a helpful thing with the Graphene bindings for Django, we get a GraphQL view. So in our regular URL patterns, where we're defining our routing, we can just attach this view. We would typically attach it to the route GraphQL. We'd only have one endpoint that will respond to requests, which is GraphQL by convention, and it will accept GET requests with the query and the parameter, or it will accept POST requests with the content of the query in the body. To our view, we're going to attach the schema, which we'll jump into in a little bit, and we can also really easily toggle on or off our graphical endpoint, which we saw earlier. So that's really helpful for local development, but if you don't have a public API, you might want to lock that down in production so that people can't poke around in your API freely. Okay, so next we're going to write our schema using Graphene. So on the left, we have our query that we saw before, same exact one. And we'll just walk through it as Graphene would resolve this query. So we have our root query object, which is on our schema. And that's just an object that we create by extending Graphene object type. On the object, on the query, we have a field story. So that we also define as a custom type extending Graphene object. We can define some parameters like ID using an interface like Graphene node. And that basically just says that we're going to accept ID as a parameter, and we're also going to provide ID to the client. For other fields, we define their types, like strings for our title. Or for passages, we would just relate that to another type that we would create. Pretty straightforward. The next step is to write resolvers for each of the fields. So a resolver is just a simple function that will allow you to find and return the data that should be resolved for that type. So for example, for our story with ID of 1 in our query, we have this resolve story resolver on our root query there. And from the arguments, we'll get our ID. And then we can use our Django ORM to get that ID, that story with that ID, and return that for resolution in the story type. So that'll go to the title resolver and just get the title from the ORM object that we passed through. It's pretty easy. With Graphene, there's also a bit of magic too. If you want to be lazy and the title field, like it matches the schema and your ORM, you don't have to write it. You can have an implicit resolver. But maybe you don't like magic and you'd rather have explicit over implicit, you can do that too. There's also like more helpers with Graphene Django bindings, but you can explore those on your own. So for mutation, it's pretty similar. We start with a root mutation instead of a query. So again, it's just a Graphene object that we create and we bind to our schema. We create the field of create story, binding to our object that extends Graphene mutation. So for that mutation, we define the inputs and say which fields are required or not. So we might require title, but not description or name. And then we write a function called mutate and get payload. So this is very simply the place where we do the change to the data. So we'll create our new story in this case, and then we'll return the payload, which is the new story that we've created. That payload will be resolved through the type that we provide here, which is just our story type that we defined earlier. So any field that's on the story type, as much or as little data as the client needs, we can ask for it here and get it back from the API. Cool. So at the end of this, you can add new fields easily without worrying about other clients overfetching data. You can modify existing fields without worrying about breaking existing clients, as long as you're adhering to the schema of types that you've provided. You can also signal for fields to be deprecated with annotations on your schema. So that's great if you have public clients that you want to give them a heads up you're going to be removing a field soon. So things are going pretty well. You can go for a jog, go to the space sauna, hang out. Things are going pretty good. All right, chapter 2, advanced API considerations. let's rewind some of our REST decisions and continue. So let's consider a time when we use proper API practices, because even with REST APIs, we can evolve them in an evolutionary manner and not get stuck in the case where we have a lot of endpoints. So maybe we were never attacked by a giant squid. So we'll just consider that never happened and keep going. So your API is beautiful. Everyone wants to use it. But you probably should use authentication. There's some scary people out there who might want to steal your data. So luckily, REST and GraphQL are pretty unopinionated. You can use OAuth, JWT, whatever works for you. Rate limiting schemas are also pretty similar, but there are more complex schemes that might be appropriate for GraphQL. For example, you could limit complexity or depth of queries, which is something that GitHub's API does really well. So if you want to have some examples of that, check out GitHub's API. Before we go into the next section, here's an example of a query that is out of control, and there's no depth limiting, so we can just keep on going. So we have our passages, choices, passages, choices, passages, choices. We can just go all the way through until there's nothing left. So you might not want people to do that if you have a public API. Okay, so scaling. So we have a robust API with all the features we need. That's great. But we're getting more traffic, and we might want to start scaling our API before it crashes and people get upset at us. So for REST, we'll go look at the next section, and then we'll look at GraphQL. So if you design your API well, scaling is something that REST does really well. While it's challenging, it's a pretty well-documented task. Pretty easy to find resources to help you do it. So it's easy to have a thin layer of caching over your REST endpoints, since we're just dealing with HTTP verbs, and each resource has its own denormalized endpoint, or normalized endpoint. You can also manage complex requests with per endpoint tuning. So each endpoint will be specific to that request, and we don't have to worry about generalizing the solution. So it seems to be pretty smooth flying. Let's see how it is with GraphQL. So things are a little bit more challenging with GraphQL. The same paradigms that work with REST don't really apply to GraphQL. So for example, we can't have HTTP level request caching because we only have one endpoint. And each time you ask that endpoint for some information, it'll be different because it could be a different query. The community at large is working on solutions for this, Apollo team particularly. And you can also do some solutions at the field level for caching, which pushes a bit more complexity on the back end. Your tuning is also at a resolver level, which is a little bit more general than the API endpoints with REST. So you might need to consider like different ways that a user can get to the endpoint or that field and use it. Another danger is serial execution of fields. So you might have all of these fields resolved synchronously, just in a row. And if you saw Piero's lightning talk, he talked about the N+1 problem, where you might have lots of database requests going out. So like for each passage and you're fetching the choices, you might fire database requests for that. So that could end up with a lot of overhead in your database very quickly. But data loader and proper configuration can really help out. So if we're doing things right and we're asynchronously resolving these resolvers and we're using data loader and promises, then the performance characteristics of the query will be more proportional to the depth rather than the number of fields in the query. And that'll just be limited by like whatever the slowest field is in there. So it's pretty good. So at the end of this, we're trying to scale our GraphQL server, alone out in space. The documentation on edge cases is thin, and Stack Overflow posts on scaring are sparse. You send out an SOS. Hopefully things turn out okay. It should be fine. Chapter 3, front-end architecture and design. This is our last chapter. It's a trilogy. We'll rewind one last time and continue. So instead of going out alone in space, you just went for a nice jog in your space station. It's fine. Okay. So for a client web application, We're trying to build a rich experience. So that means we might need to write some JavaScript, which this is not a JavaScript conference, but it's our lives as web engineers. So let's take a look at REST. So for REST, we have many endpoints in our robust API. With a really large set of endpoints, service discovery can be a challenge. Especially on a big project where lots of developers are working on things, it can be hard to know which endpoint might have the information you need and where you should be sending information. So things like Swagger can help you in this with automatically generated documentation, but there's not really a standardized way to go about it. So after you identify your endpoints, you're ready to write some code. But unfortunately, you might need to write a lot of boilerplate code to handle interaction with your API, like asynchronous fetching, error handling, data normalization, and caching. And that means more JavaScript, which we don't want to write as much as JavaScript as we want. We want to write more Python. So further optimization might be needed as well, especially if we have a very normalized API. We might be dealing with underfetching and optimize for n+1 requests on the front end. So basically that means, for our passages, we might get the passage and then need to reach out to the API for each choice that we need to get or whatnot, depending on how robust our API is. So at the end of all this, your front-end code becomes very complex. It's a cage of complexity. You're surrounded by n+1 HTTP requests, and there's no escape. Gulp. That's no good. Let's try it again with GraphQL. So luckily, with GraphQL, APA documentation is a first-class citizen. So we have auto-generated documentation that we can explore and prototype with queries using GRAPHOL, and it's a pretty awesome tool, great experience. You might choose to use a GraphQL client in JavaScript, like Apollo or Relay, to manage some of the complexity of interaction with your API, which can lead to hundreds or even thousands of lines less JavaScript, which is great. We want less code in general, and we also want less JavaScript. These frameworks are a little bit opinionated, though, so you might need to structure your API to serve them. So you might need a globally unique ID for each of the types, which Graphene can help you with. But that helps reduce the complexity for caching on the front end by a lot. You might also need pagination for Relay using a connection pattern, which can be a little bit confusing at first, but it's useful as a tool to build your API. So let's look at some code in JavaScript using Apollo and React. So again, we have our query from before. We're just getting our story and the passages related to it. And we're going to connect that query to our React component, our story component, using a higher order component. This is a common pattern in React that is used in Redux and other places. If you went to Patrick's talk yesterday, you may have seen the query component, which is a new paradigm that they're trying to introduce, which can be a little bit cleaner. But yeah, anyway, by connecting to our query through Apollo, we get our loading, error, and data props in the story. So we can use loading prop. It's a Boolean that tells us if we're loading or not. And we can use that to display a spinner or some other kind of loading state. If there's an error, we can display a fallback UI with an error message or with some kind of error reporting system. And if we get the data back fine, then we can just use it pretty easily by using the data prop. We also have the ability to pass through parameters through props in our GraphQL query. And the setup is pretty straightforward. All we need is an Apollo client and the URL of the endpoint. So that's pretty easy. Let's look at mutation. So again, we have the same mutation from earlier. And we'll use the same higher order component pattern to connect that with our React component. We can map the mutate prop that Apollo gives us to a callback that's a little bit easier to handle. So we'll call that callback handle create story, and we'll pass in the title, author, and description. And just have a button that we can click on. So this is a pretty contrived example, but you can see it's pretty straightforward to get that going in your front-end application. We can also write code for handling optimistic updates, which will allow us to improve perceived performance by having the front end predict what the response from the GraphQL API is going to be and immediately showing that to the user, regardless of latency. So we're making more efficient requests from our server. We're writing less boilerplate code. And we can easily improve the performance through caching and optimistic mutations. That's awesome. So let's celebrate. Everything's coming together. Let's have some pie with our friends. It's a good time. All right, let's go on to the next section. So to wrap up, it was hard work, but we built a robust web application and API backend. GraphQL was useful as a general purpose API with a productive framework for development, but REST is still a proven and scalable solution. Next time, what will you choose? Maybe REST, maybe GraphQL. All right, thanks.
Any questions?
Hi, thanks a lot for the talk first, and the art style is amazing as well.
Thanks.
I wanted to ask, like, when you build GraphQL APIs, do you have any special considerations about testing them automatically? Like, how do you write? Like, is there tooling for end-to-end tests, for example, or how do you unit test them, all your resolvers and all your functions and stuff?
Yeah, so there is a testing tool that was introduced by the author of Graphene for doing snapshot testing, which is pretty similar to how JavaScript and Jest do snapshot testing, where you can kind of do like a very easy like integration test where you send a query with some payload and you expect some kind of a JSON or dictionary response, since we're testing in JavaScript. So it's pretty easy to write those kind of integration tests. And for a lot of other like more complicated things, you might just want to extract that logic out into a service so you can easily test it over there. Cool.
Any more? No one? Okay. Thank you, everyone. Thank you, David.